MCP Python Hooks, live runtime demo for Python MCP servers. When building Python MCP servers, we can see the requests coming in, but we often can't see what those servers are actually doing at runtime. The tool calls, the imports, the in-network reads, or what's happening under the hood. To solve this, we built Python MCP Hooks. Let's take a look. We start by cloning the public OSS repo from scratch at github.com/bluerock-io/bluerock. This is just to show an example we ship along with the MCP hooks themselves. Next, we activate the virtual environment and install the BlueRock OSS package. This single command pulls in the MCP hooks along with the Rust DSO backend, which is responsible for writing the events out into NDJSON. Then we install pip, fastMCP, and the MCP libraries. These are dependencies for invoking our MCP server and client. A single config file is responsible for enabling our MCP hooks and MCP import tracking. Here's the server we're going to instrument. Let's take a look at a Linux admin MCP server. We have a few command operations and curl tool calls that the server can handle. The server is connecting through the SSE protocol, using the port we set up for persistence so other clients can connect. Now let's invoke the OSS. You can see the events being written into NDJSON in real time. The server initialization, the server getting added, everything is recorded. Nothing gets missed. You can see the server has initialized on the left. Let's invoke the client. Before we begin, let's take a look at what the client does. We have a simple interactive REPL that connects to the server using the SSE protocol. It makes a few tool calls, lists resources, and prompts. The client connects to the same port as the server we launched earlier. Let's invoke the REPL client so we can communicate with the server and observe the client connections being recorded. On the right, we can list the tools available to this client and see those events being logged as well. Now, let's invoke the run command, for example, myenv, and notice that this action is recorded too. Next, we try myIdentity, and then a simple curl command. Both of these calls are being invoked and recorded on the right. Each call becomes an MCP event for the Rust DSO backend and is written into the NDJSON resource. For example, the sample command is a simple read command for the server to execute, and we can see these actions being recorded too. Next, let's try running a prompt that the server has already received, such as a JavaScript or any other language prompt. We can see the MCP events generated from this. Let's now check the actual NDJSON file that the hooks have recorded for us. We can review the types of commands that the events have captured and see each command being logged. Let's also look at the libraries that have been imported, along with their SHA 256 sums. Each library is monitored by our import monitoring system. Finally, let's reconnect to the same server using the MCP client. We can see that the client is connecting again. All those events are being recorded. Let's run a sensitive command, so any rogue agent or anything that operates underneath the hood and might get missed. Those events are being recorded and processed. We can also see that that has been recorded and the MCP session termination has happened. Let's quit the server. Whew, that's about it. The network reads, every URL being fetched. We are seeing these 3 live signals at once. The server logs the protocol, the client shows the results, and at the bottom, we can see the sensor events as they fire. The resource reads, captured prompts, session lifecycles, open, close, everything. The full MCP server is instrumented out of the box, and structured payloads sit behind those events. Every shell command, every URL, every import is tracked for tamper detection. Supply chain attacks are detected here first. This isn't just logging, it's structured runtime context. We can route into ODL, Grafana, or any observability stack you're already using. So that's the full picture, from startup to every tool call, every import, all as structured events with one command and no code changes. We built this for the MCP community. We'd love to hear what you do with it. You can find it at BlueRock.io.